To solve this equation or system of equations by elimination, I'm going to try to again wipe out the x's, and to do that you're trying to think about a number that both -2 and 4 will divide into, and they'll both divide into 4, and this one's already set at 4. This one will need to be a -4 so that when I add them together the x's drop. It's already a -2 times 2 will give me the -4 that I need so that it'll cancel out. So when I go to write this one up, the top equation is what you're multiplying through by 2. Again, I just wiped out the x's. I could have easily wiped out the y's. In this case, it's kind of what's going to happen. Remember, everything has to be multiplied by the number on the outside. I just put m for multiply. And then 4x. Okay, so when I add these up, my x's cancel, but then so do my y's. So again, I end up with a big 0 on the left side. But on this side, I also end up with 0. I've lost my x's and my y's, so it's the unique case again. But this time the statement's true all the time. 0 does equal 0. I didn't come up with a false statement, which means there's infinitely many solutions. Now, in terms of a picture, what that means is these two lines were exactly the same. They were one was sitting right on top of the other one. Or just something kind of like that. Actually, the y-intercept would be at -3, but the idea is one line sits on top of the other line. How do I denote that? I can't just say many solutions, because many solutions, if they're on the line, they're solutions, but here's a point, but it's not on the line, so it's not a solution. So to be a little bit more specific, the way that you write your final answer up looks a little strange, but hang on. We're going to say it can be any x, and normally we'd say it can be any y as well, but we want to be a little bit more specific. We don't want this point out here. We want all the points on the line. So what we're going to do is take one of the two equations and solve for y. Alright, it doesn't matter which one you pick because they're both the same equation. So I'm just going to pick the one with the smaller numbers in it. I'm going to take -2x plus y equals -3. Solve for y. So I'm going to get y equals 3 plus 2x. That's what I'm going to plug in for the y value right here. So my point is I can pick any x I want, but the y has to be specific, and it has to fit into the 3 plus 2x. This is your final answer. Alright, so kind of to recap, once I see that I have 0 equals 0 and it's true all the time, I can let x be anything I want, but the y has to specifically fit on one of these two lines, and they happen to be the same, so I'm going to pick one of them, solve for y, and then put that in as my y coordinate. This is what you would type in or write down as your final answer on a quiz, test, or in MyMathLab.